SRVCC stands for Single Radio Voice Call Continuity. SRVCC solution is used when the VoLTE calls cannot be continued due to coverage holes of LTE network. In such cases, SRVCC allows a packet switch VoLTE call to transition to a legacy circuit core network. It's a basically handover of ongoing voice calls from the IMS network to circuit switch legacy systems such as 3G without dropping the call. This is a light-hearted, easy to understand summary of 3GPP specs. What is SRVCC? Have you ever wondered what will happen when the user makes 4G voice call and moves into low coverage area where 3G network is available but 4G network is not available? Example: you move into left of building or goes into basement or travel by metro where radio coverage changes very rapidly. In these cases, LTE may not be available. Here, we use the technology by the name of SRVCC to ensure voice call continues and is handed over to 3G network without dropping off the call. Name of this technique is Single Radio Voice Call Continuity, and this VoLTE feature is developed on later stage as an enhancement. By using SRVCC, the mobile operators are able to make the handovers while maintaining the existing quality of a service. The SRVCC requires only a single active radio in the handset and requires some upgrade to the supporting network infrastructure to support this feature. Now let's understand the evolution of a voice call. Here we'll see options available with the user to make or receive calls on the network. On the left hand side we can see it's a 2G legacy network. Voice calls are made practically only on the circuits for each call on circuit switch domain. While we move to 3G, it's more or less similar to 2G networks. No major change other than supporting some advanced codecs. Now comes CSFB, which is used in the operators where LTE have been launched without support of VoLTE services. The next one is the VoLTE itself. Next one is SRVCC extension, where we allow handover of a call from LTE to 2G 3G network in case there are coverage holes in the 4G network, such as lifts or basements, as we have discussed in the earlier slide. The last one is the enhanced SRVCC and alerting SRVCC, which reduces call switching time when the user moves from 4G to 2G or 3G radio. This improves user experience to a greater extent. Now let's understand the various approaches which are available with us for handling a voice call in a network. Here I am going to show you working and differences between the CSFB and the SRVCC. On the left hand side you can see it's a CSFB. On the right hand side you can see it's a VoLTE plus SRVCC. Now let's start with CSFB approach. CSFB stands for Circuit Switch Fallback. This is applicable to operators where LTE is launched but VoLTE is still not supported. Since LTE itself doesn't support voice and it's all IP to IP network, it uses legacy 2G 3G networks for providing voice services to the user. There is SGS link created between MME and MSC for handling incoming and outgoing call communication. As you can see in the diagram, immediately after initiating the call, user is thrown in 3G network where it can camp on RNC and can make or receive calls. This is a temporary solution and will eliminate over the time once all the operator upgrade to VoLTE services. Now let's discuss VoLTE plus SRVCC, which is there on the right hand side. SRVCC stands for Single Radio Voice Call Continuity. Basically, SRVCC is a call transfer method or handover which is implemented in a simplified and in a reliable manner. When an LTE user has an active voice session in IMS and is moving to the areas which have legacy 2G 3G coverage and doesn't have LTE coverage, for example, you can see one LTE coverage hole on the top right corner of the screen. The user moving to this area will lose LTE coverage and uses SRVCC. Now this SRVCC will help this particular user to continue the voice calls using the VoLTE initiated in LT coverage area down the line in 2G 3G networks. The main advantage of this solution is the call will not drop but will only be transferred to the CS domain on the legacy networks. However, the signaling required is very complicated in such scenarios, and there is a new interface which is introduced by 3GPP by the name of SV. Unlike CSFB, this is a permanent solution and this is going to stay along with VoLTE for a longer duration. Although CSFB and SRVCC cannot be compared because CSFB is a service-based handover procedure while SRVCC is a coverage-based handover procedure. I'm still trying to convey some of the benefits which VoLTE plus SRVCC approach brings to the users or to the operators as compared to the CSFB. The first one is the call setup time. When operator uses CSFB, one of the biggest problem faced and one of the major disadvantage of CSFB is the increase in the call setup time due to retuning procedures required for 2G 3G radio. In other hand, VoLTE provides a faster call setup time. The second one is the call quality. Call quality in VoLTE is better due to specific QoS allocated to the IMS call, and the codecs which are being used in VoLTE or IMS, they are far superior than legacy networks. They can provide a better quality which is not there in the 2G or 3G legacy networks. The last one is the resource benefit for VoLTE. Codec use in VoLTE requires much less resources and it consumes much lower data rate as compared to CSFB, which is working on 2G or 3G networks using a dedicated circuits. Now let's understand the evolution of the SRVCC. These are various evolution of SRVCC which are introduced by 3GPP between release 8 to release 11. So at the end of the day, these enhancements or evolutions or the new things which are introduced by 3GPP, they are going to increase the user experience to a greater extent. So let's start our journey with the basic one. The first one is the basic SRVCC which came in release 8, and this addressed the basic issue of call continuity from LT to 2G 3G networks. Second and third option are ASRVCC and ESRVCC, which helps in improving user experience by reducing overall switching time. They will be covered in later part of this video as I want to keep things really simple at this point of time. The fourth one is the VSRVCC, which is video SRVCC. The last one is RSRVCC, which is introduced in release 11. This provides the continuity from 3G to LT. It's reverse to the SRVCC which we discussed in the beginning. You can also refer to 3GPP document TS 23.216 for further study which covers all above flows in depth. ASRVCC and ESRVCC are widely used in many mobile operators and these helps to improve overall VoLTE user experience. We are going to cover this particular portion in the end of the video. Now let's understand, how SRVCC works. The 3GPP have introduced a special link by the name of SV between MME and MSC for enabling SRVCC functions. This SV interface runs on GTP v2 protocol. With the help of SV interface, both MME and MSC talk to each other and exchange information pertaining to user who is going to perform SRVCC. Let's see what happens in the life of a user. We can clearly see here a user is latched in the LT network as visible on the screen. Well, now he makes a MO call to another IMS user. The voice path used here is shown in yellow color. Since user is moving on to low coverage of LT network, user informs eNodeB that I am running out of LT signal. MME in turns uses SV link and asks MSC to take charge of this call. As a next step, MSC align the resources and establish connectivity with IMS so that it can take full control of the call once user latches on to 3G radio. Once everything is aligned, MSC informs MME. Now MME asks user to release 4G bearer and go to 3G radio. Now user tune to 3G radio and contact MSC, which is already aligned to receive calls. Here MSC patches this ongoing call from 3G radio with IMS network without dropping off the call. Okay, this is a SRVCC call flow. This is an extract from 3GPP specs document TS23.216. Here we can see complete ladder flow diagram. This tells us how SRVCC works and how user move from LT radio to underlying 3G radio without dropping the call. Just like normal data handover, this is also divided into two parts. The first part is the handover preparation flow, where all the readiness and resource reservation is completed prior to the actual handover of a user. The second one is the handover execution flow, where actual handover happens and call gets switched to 3G radio. We'll cover that flow once we understand the handover preparation in nitty-gritty in detail. Okay, let's start our journey with SRVCC call flow. We can see customer happily latched onto 4G network here. You can see this blue color is a 2G 3G coverage, and the orange or a yellowish color is a LT coverage. As visible, the 2G 3G coverage is widely available everywhere, but 4G coverage is very limited. So we'll understand what will happen to a life of a user once this particular user moves out of this LT coverage to a 2G 3G coverage. We'll understand how this SRVCC works, how this particular call gets handed over and switched to the 2G 3G networks. As a first step, the user makes a VoLTE call on 4G network, which uses the path of eNode B to SAI gateway to the IMS core. Now UE starts moving away from the 4G coverage and started getting good signals from the 3G network. At this point of time, the handset realized that 4G signal levels are beginning to decrease. The user tells eNode B that current radio levels are declining, and it does this with the help of the measurement reports. Now the eNode B takes decision and identifies the best available network to receive the call. The eNode B sends the handover request to the MME with SRVCC handover indication. This will tell MME that there is a handover which is required for both CS and PS, and there is an ongoing call which has to be handed over for SRVCC. After receiving the SRVCC handover indication, the source MME splits the voice bearer from all other PS bearer and initiates their relocation towards MSC server and SGSN. This MME does two critical things here after bearer splitting. The first one is the MME initiates the PSCS handover procedure for the voice bearer by sending a SRVCC PS to CS request message to the MSC server. This contains critical information such as IMSI, the target IDs for the voice calls. It also contains STNSR, CMSISDN, etc. We will understand the significance of these parameters such as STNSR and CMSISDN in the end of this video. In parallel, MME indicates relocation of PS bearers. MME sends the forward relocation request to the target SGSN. This is required for handing over the internet session which was running earlier in 4G network. Now we are going to hand over both voice as well as the data session onto underlying 2G or 3G networks. So this MME to MSC side communication on the right hand side takes care of the voice flow. On the left hand side, the communication which is happening between the MME to the SGSN takes care of the internet. Now both MSC and SGSN will approach the RNC of a 3G network by requesting resource allocation for the CS and PS. Target RNC acknowledge the PS and CS relocation handover by sending the relocation handover request acknowledgement to the respective SGSN and MSC here. SGSN acknowledge MME by sending forward relocation response back to MME. You can see these acknowledgements coming back in the green color arrow. Once MSC receives relocation handover request acknowledgement from the RNC, it needs to set up CS lag with the IMS network. The MSC server indicates the session transfer by using the STNSR with the IMS network here. In actual, the MSC sends a new call ISUP-IM message towards the IMS with STNSR as a destination. This newly established call between MSC and IMS network is used to carry voice once handover is completed. Now it is the time to change the flow of a voice traffic. The standard IMS service continuity procedures are applied for execution for the session transfer. Here there are two critical tasks of session transfer and update remote lag is done to divert the flow of downlink flow of VoIP packets towards the CS lag via MSC. Earlier they were going via the P gateways and via the LT network to the users. Now they have been switched to the MSC via circuit switch domain. The IMS lag to the packet core is now released. It is shown in the red color on the left hand side. Now the traffic is diverted from the packet switch network to the circuit switch network. The MSC server sends a SRVCC PS to CS message to the MME. You can see this in the blue color arrow going from all the way MSC to MME. The MME sends the handover command message to the eNode B. In turn, the eNode B sends a handover command message back to UE, which is a direct order to the user that go to 3G radio and switch and latch onto 3G radio. Please go to 3G radio and camp onto that. Leave 4G radio right away. With this, we have completed the handover preparation flow where all the resources have been reserved. Let's move ahead to the second phase of handover execution. Wow. In order to complete handover, now user camps onto 3G network. You can see user getting signal from the 2G 3G radio in blue color as mentioned on the screen. This is a reference ladder diagram which is also extracted from 3GPP document which explains us the handover execution flow where the actual handover execution happens. Now let's jump on to the understanding of these flows. It's fairly simple as compared to the earlier discussion and the flow which we have gone through. Now let's understand what happens to the user once the execution of the handover happens. The user tunes to the target UTREN or GREN cell. It means the user is now latching on to the 2G or 3G radio down the line. Handover detection is happening on the target RNC or BSC. The UE sends a relocation handover complete message via the target RNC BSC to the target MSC. At this stage, the UE re-establishes the connection with the network and can receive or send a voice data. Now MSC server sends a SRVCC PS to CS complete notification message back to the MME. The MME acknowledge the information by sending us SRVCC PS to CS complete acknowledge message to the MSC server. Here the MME deactivates the voice bearer towards S gateway P gateway. The MSC server performs the other procedures such as TeamZ allocation. It also does map location update with HLR HSS to complete the entire flow. Now all the steps are closed and the voice is flowing on the new path. Similarly for data, as you can see on the left hand side, the handover completion and the bearer updation is done between SGSN and P gateway so that user can start the internet session on 3G radio now. With this, we have already completed the handover execution flow, and SRVCC overall call flows have been already explained. Now let's understand the nitty-gritty of the rest of the elements like STNSR, like ESRVCC, like other things which are actually required for day-to-day handling of SRVCC based stuff. Now first we discuss the SRVCC identities which are being used on day-to-day basis in the network. We are going to discuss identities which are used for SRVCC functionality. The first one is the STNSR. The STNSR is a session transfer number for SRVCC used by MGCF for routing the call towards the IMS network. This follows the E164 telecommunication number format and is used by the MSC server for session transfer of the media from the PS domain to the CS domain. HSS provides the STNSR to the MME that is provisioned for user against its attach procedure. The MME sends this STNSR which was received during attach down the line to the MSC in SRVCC PS to CS request. The MSC initiates a request for an access transfer of the active session from the IMS network and includes this STNSR in the request. Now let's understand the flow. HLR gives the STNSR to MME. MME gives STNSR back to the MSC. MSC now use this STNSR to route the particular call to the IMS so that the ongoing call can be switched on this particular path which is being created between MSC and IMS using the STNSR as a B number. There is a new element. The SCCAS eventually receives the invite with the help of STNSR, which indicates the need of an access transfer for an active session. We'll discuss SCCAS also on the later part of the slide. The STNSR is the number that is used to facilitate all this coordination of a voice call. The second one, as you can see on the screen, is the CMSISDN. There is a correlation MSISDN, also known by the name of CMSISDN. It is used for the correlation of a session at an access transfer and to route the call from the IMS to the same user in the CS domain. Now let's understand the network changes which are required for enabling the SRVCC. SRVCC started evolving from release 8 and it continued till release 10. The network upgrades required for the mobile operators are needed in both LT network as well as in legacy networks. Now let's understand which all network elements do we need to touch if we are going to launch the SRVCC. The first one is the ATCF. ATCF is a signaling controller that facilitates the handover from the LT to the circuit switch 2G 3G networks and updates the VCC application server. VCC stands for Voice Call Continuity Application Server. These ATCF and AT gateway enhancements will be implemented in the SBC. The second one is the AT gateway. It is Access Transfer Gateway. It acts as an anchor for the IMS media traffic to allow media traffic to be switched quickly from the PS access network to CS access network via MSC. Now these changes in ATCF and AT gateway are required on the ESRVCC. Now next one is the changes which are required in the MSC server. MSC is the center of all the communication for SRVCC. It handles the relocation preparation procedure with MME via SV interface, and it also handles the session transfer procedure with IMS network. It should support the STNSR and so many SRVCC specific parameters. The next one is the EUTRAN. EUTRAN is a 4G radio which selects a target cell for SRVCC handover. It is required to send an indication to the MME that this handover procedure requires SRVCC. The next one is the MME, which should support the SRVCC functionality such as bearer splitting, SV interface, STNSR communication with MSC, and so on and so forth. Some changes also required in HSS, like it should provision STNSR, it should also provision CMSISDN, and should pass on these parameters back to MME while a user is attaching onto the network. Now there are two new elements which have been there. The first one is the SRVCC IWF. This is single radio voice call continuity interworking function. This is a new node altogether which was introduced in IMS network, which eliminates the need of MSC upgrades. I mean to say, if you don't want to touch your MSC infrastructure, you can simply put up a box with SR VCC IWF functionality, and now this nodes can do all the jugglery and all the communications which is required between the MME and the MSCs down the line. It connect MME on the one side of a network and it connect MSC on the another side of a network. The last one is the SCCAS. This is also a new node which is introduced for SRVCC. The SCCAS is an entity which combines the SIP signaling and act as a back-to-back user agent. This provides an anchoring point for incoming and the outgoing call. Now let's understand the ESRVCC. There are few advancements introduced in SRVCC in order to improve overall user experience. In the plain old SRVCC, the home network application server SCCAS anchors the call. This anchoring by home network tend to increase the handover delay in case of a home subscriber roams to a distant network and latches onto the roaming partner. This effectively means the call must be routed back to home network for any SRVCC handover happening in the network. This problem is very significant to the countries where national roaming prevails. There is a major change done here with ESRVCC. In enhanced SRVCC, an ATCF-AT gateway is introduced to anchor media sessions. All session messages before and after the handover must exchange through the ATCF-AT gateway in serving networks only. Only bearers between the calling UE and the ATCF-AT gateway need to be updated. This shortens up the entire speech gap. Along with ESRVCC, we got another feature of ASRVCC, which is also known as SRVCC in alerting phase. This adds the ability to perform access transfer of a media of an IM session in PS to CS direction in alerting phase for the access transfers. As more and more operators trying to roll out the LT and adopt VoLTE IMS as a platform for providing the voice services, SRVCC will be an option for addressing the gaps in the LT coverage while providing the continuous coverage of the voice services. Despite the fact that SRVCC is apparently more complex than CSFB, this continues to be the choice of the mobile operators due to benefit coming to us from the VoLTE services. SRVCC plays key role in providing uniform services across the EPC domain. Now you can go through the above specs for further studies on this domain. We have completed the SRVCC tutorial here. In case of any queries or doubt, feel free to put your comments. I'll revert quickly on the same. If you want to download this PPT or video, please visit my website. It's telecomtutorial.info. Hope this video presentation is useful to you. Please feel free to like, dislike, comment and share. Please subscribe to my YouTube channel for more technical videos. Thank you.